Math 70, Section 9.1, Square Roots. We are going to evaluate square roots of perfect squares and determine whether a square root is a rational, irrational, or not a real number, and we're going to find the square root of variable expressions. So when you take a number like 5, any number, and raise it to the second power, it's called squaring. Squaring it. So if you had 5 squared, that is 25. Well, what if I want the inverse of squaring a number? That's called square rooting it. And we use the symbol, which is called the radical sign. The number underneath is called the radicand. And there's a number right here, it's invisible, it's the index. And the index, I'm going to put it here. If you don't see a little number on that ledge, it is understood to be 2. So it's kind of like 1x. You don't need the 1 in front of x. Or x to the first power. You don't need the power. So you're not, with square root, you will not see that 2 there. When you get to cube root, that's what cube root looks like, 4th root, 5th root, and so on. The number will be, that little number on the ledge will be there. But for right now, we're talking strictly about square rooting it. So when you take a number and raise it to the second power, that's called squaring it. To find out what number, let's say we don't know this. If I want to know what number squared is equal to 25, what number squared is equal to 25, you are going to square root it. It's the inverse of squaring a number. So this is asking you what two numbers that are the same that multiply to give you 25. Now, if I gave it to you in this form, x squared equals 25, and I said, what two numbers multiply to give you 25? Well, there's 2 answers, 5 and negative 5. Because 5 squared is 25, and negative 5 squared is also 25. So when it's written in an equation like this, there are going to be 2 answers, plus and minus. If I only want the positive answer of this, I don't want the negative answer, I'm going to use the radical sign. And in this case, I would do that, square root of 25, and I'm going to ask myself, what 2 numbers multiply that are the same, multiply to give me 25? Instead of saying 5 and negative 5, we're just going to say 5. This is called the principal square root. So when we only want the positive answer, we use the radical sign. Okay, so now we're going to evaluate these square roots. Okay, so example number 1. Okay, so you're asking yourself, and we only want the principal square root. So for A, it says the square root of 36. This is asking you what 2 numbers multiply that are the same, multiply to give you 36, because it's understood 2 square roots. So 6 times 6 gives you 36, so the answer is 6. For B, square root of 1/9. So this is the same as the square root of 1. You can break this up over the square root of 9. So what 2 numbers that are the same that multiply to give you 1? And that would be 1. What 2 numbers that are the same that multiply to give you 9? And that would be 3. So the square root of 1/9 is 1/3. For C, the square root of 0.01. What 2 numbers multiply to give you 0.01? And that's 0.1. 0.1 times 0.1 is 0.01. So this answer is 0.1. And for D, square root of 2.3. Now there's two of these. So, and this is getting kind of jumping ahead to one of the properties. So this is saying square root of 2.3 times the square root of 2.3. Now, when the indexes are the same, and we're going to talk about this in one of the later sections, when the indexes are the same and you're multiplying, you can put them both under the same radical. And you get 2.3 times 2.3, which is two of these, and your answer is 2.3. Now, we're going to talk about perfect square. If you can find two numbers that are the same to give you that number, which is called that's the radicand. 36 is the radicand. The number underneath the radical sign is called the radicand. So if you know the two numbers, it's called a perfect square. So these three are perfect squares, but this one is not a perfect square. Okay? Let's do some more evaluating. So this is just a little more involved, like you may have to do some adding, subtracting, whatever. So A says -4 times the square root of 36. So first you're going to evaluate, think of this as a grouping symbol. What two numbers multiply to give you 36, square root of 36? Well, 6 times 6 is 36. So the square root of 36 is 6. So you have -4 times 6, which is -24. For B, it's asking you square root of 9 plus the square root of 16. Now, when you're adding, do not add these, do these separately. You have to think of this as a grouping symbol, and this is a grouping symbol. So evaluate, what is the square root of 9? What two numbers multiply to give you 9? That's 3. And the square root of 16 is 4. And then do adding. 3 plus 4 is 7. If you were to have added these, this and this, you get 25, and the square root of 25 is 5, so you're not going to get the same answer, so please be careful. Now that shows you on letter C, if you add, now you're going to add these, so there's a difference between these two problems. The square root of 9 plus 16. Well, now you're going to add these up to get 25, and the square root of 25 is 5. And D, you're going to first do the order of operations. So in this case, do not subtract first. You have to follow the rules. The rules say do this first. 4 times 7 times 1 is 28. Okay. And subtract, you get 36. And the square root of 36 is 6. Okay. Okay, next. Now we have to deal with whether or not the square root is rational, irrational, or not a real number. So, first of all, the number underneath the radical sign, which is called the radicand, I'm going to say that over and over. This is the radicand, and the index is 2. That's the radical sign. So, can you think of two numbers that are the same that multiply to give you -16? You cannot, because if you're multiplying two numbers to get a negative, one has to be positive, one has to be negative. So if the index is even, 2, 4, 6, 8, this number cannot be negative. This is not real. Now, when you get into the higher levels of math, you're going to use the letter I to denote that it's an imaginary number. So this is, for right now, this is not a real number. So you may have learned in other classes that the square root of -16 is 4i. which that's in the complex number system. So just for now, anytime you see the square root of a negative number, it's not real. You can't do that. Now, what happens when you take the square root of numbers like 36, 25, 100? Those are rational numbers because I can come up with two numbers that are the same that multiply to give you that. These are called rational numbers. Now, if I asked you what's the square root of 3, what two numbers multiply to give you 3 that are the same? That's an irrational number because the only way I'm going to be able to do that is use my calculator, and I'm going to have to hit square root of 3. When I come up with an answer, you see on the calculator, sorry, it's blotchy, but it's 1.7320500808. This number goes on forever. There's no repeating. That's what we call an irrational number. An irrational number is a number that goes on forever, does not repeat, does not terminate, it doesn't end, it keeps going. So the square root of 3 is an example of an irrational number. Okay, so look at example 5. The only way I'm going to be able to figure out what the square root of 5 is using a calculator because it's an irrational number. Okay, I know that the square root of 4 is 2 and the square root of 9 is 3. So the square root of 5, which is between 4 and 9, has to be somewhere, the answer is going to be somewhere between 2 and 3. So I need technology. I need to do square root of 5, hit enter, and it's approximately 2.236067978. That's an approximation. So an exact answer, you always leave the number as a square root. But to estimate it, you have to round, and I would say 2.24 would be the answer. Read what they're asking you. Write it as a decimal rounded to 2 decimal places. Make sure you understand the second decimal place is a 3, so you look at that 6. 6 tells you to bump up that 3 to a 4. So you have to know rounding too when you're doing these. So real quick, example 4, they're asking you to find what the answer is and then determine whether that's rational, irrational, or not real. So for A, the square root of 51. I don't know what two numbers multiply to give you 51, so I need my calculator, square root of 51, enter, and the answer is 7.14. That's an irrational number. This number, it's not a perfect square, it's going on and on and on. So this is approximately 7.14. For B, square root of 169. I know that 13 times 13 is 169, so the answer is 13, and this is a rational number because this is a perfect square. And for C, C is not a real number. You can't take the square root of a negative number, so this is not a real number. Okay? When you're doing variables, treat them like it's a number. The only thing is when you're taking the square root of a variable, you're going to use the absolute value sign. The square root of a variable expression raised to the second power is the absolute value of the variable expression. So for example 5, the square root of 7 squared, well, think about it like this. 7 squared is 49, and square root of 49 is 7. Or you can think of it as 7 times 7, because you have 2 of them, and then the square root of 7. For B, B is a good example of why you use the absolute value. If you take negative 15 and square it, this is asking you the square root of negative 15 squared. Now, negative 15 times negative 15 is 225. Okay, you're squaring a negative. So the square root of 225 is 15. Or you can think of it as like this. You're going to take, you have two of these. It's the absolute value of negative 15, which is 15. For C, you're going to, you've got, because of this case where you have, if it's negative squared or if it's positive squared, it's always the positive answer. So for C, you're taking, you've got x squared. We don't know if x is going to be negative, a negative number like this one, or if it's positive. So what we do is we take the absolute, we want to make sure that we say the absolute value of x, because it could be positive or negative. But we want only the positive one. By taking the absolute value, you're going to make it positive. So same with D. D says we have, it's the square root of the quantity 3x minus 1. There's two of them. So you have 3x minus 1 times 3x minus 1. You have two of these, so the square root of that, is just 3x minus 1. But we want to put absolute value on it because we don't know what x could be. It could be positive or negative. So make sure you take the absolute value of it. And for E, E is asking you, it's giving you a polynomial, x squared plus 6x plus 9. You need to factor that like you did in the previous section. So this factors is a perfect square trinomial. It factors to be x plus 3 times x plus 3. And you have two of them. So the answer is x plus 3, but take the absolute value of it. The end.